A while ago, I wrote this article on Medium, specifically on TowardsDataScience, which is the section of Medium dedicated to data science topics. The article explains how to connect Azure AI Search, a semantic search service on Azure, with Azure OpenAI to create smart search solutions within private data, known as Retrieval Augmented Generation, RAG solutions. The article is quite detailed, taking about 20 minutes to read, and aims to explain the elements needed to configure the solution in a controlled and informed way. Since I'm still getting many questions, even weeks after the article was published, my goal in today's video is to help you quickly and practically implement these solutions. I won't repeat the details in the article, but I will show you how to build a RAG solution with hybrid search using code, or at least in a scripted way for better control and reproducibility. I will use the online interface to quickly get the necessary code, but we will execute all commands via REST calls from my Visual Studio Code environment. The code I show is also better structured than what would be auto-generated by AI search on the Azure portal. For example, I use variables rather than constants for object names. The service asks keys instead are kept in the separate settings.json file in the VS Code subfolder. And I will update these secrets before publishing the article, of course. One last note before starting. The goal of this demo is to build a hybrid search solution with Azure AI Search and OpenAI, where the documents are in this data folder of a blob storage container. The documents I have already uploaded are the 3 public PDFs about how to make a pizza at home, major historical events from 40,000 before Christ to today, and a technical guide for the Microsoft Surface 7, which is quite old, but anyway, that's it. So let's get started. Open the Azure portal where we find the AI search service and the storage account with our data. Check the search service, which is empty with no data sources, indexes, indexer, or skillsets so far, of course. Create the data source using the Azure interface. Specify the storage account, the container, and folder, and enable deletion tracking, which allows the indexer to delete information from the index when the corresponding document is deleted from the storage. Configure the storage for added security. Access the storage with the system-assigned managed identity of AI search or user-assigned, which has the storage blob data reader role. And in data protection section, please enable soft delete for blobs. Confirm these choices in the data source wizard and it is created instantly. Let's look at it. The JSON shows the structure we could find in the documentation under create data source. Now delete the data source and I'll show you how to recreate it from code. I have installed the REST client extension in VS Code, but you can use your preferred client for REST calls. The request body for the data source is what we saw earlier, but parameterized. For example, you can switch the connection string from MI to managed identity to key-based authentication. This request is also instant, and we see it reflected in the Azure portal immediately. Now that we have the basics, we could proceed similarly to create the index, the skill set, and the indexer. But for convenience, I'll show you how to do all these steps using the AI search wizard, which helps understanding the steps, and then we'll complete the exercise with Visual Studio Code commands. The wizard is here, import and vectorize data. The first step asks for the data source, the blob storage, container, and folder from earlier, which it uses to create the data source. The second step asks how we want to vectorize the text, which is really important, because beyond the configuration, it asks for an OpenAI service with an embedding deployment. As we see, I have 3 deployments, and I will choose text embedding 3 small. It's important to understand what's behind this. The wizard implicitly splits the text into chunks, which are small portions of text, and puts each chunk in a different row or record. Technically, it's called search document in the index with the corresponding embedding. In practice, will find a field called chunk with text, a field called chunk vector with its 1536 embeddings, a reference to the main document, and other information. The OpenAI service specified here is not for creating embeddings or chunks, but for converting search questions into embeddings, on which Azure Search will calculate the semantic, also called cosine distance from the chunk embedding. The embedding creation instead for the index is done by a skill in the skill set, as we'll see in a minute. But the deployment, of course, must be the same for compatibility. The third step allows adding AI skills unrelated to embeddings or OpenAI, like extracting text from images, OCR. Confirm this by specifying the multi-service account service for this task, which is different from an OpenAI service. The checkbox instead for vectorized image also requires the same type of vision service needed for OCR. Image vectorization, on the other hand, has nothing to do with text vectorization or for OCR. Image vectorization produces 1024 embeddings, while OpenAI small produces 1536 and large produces 3072. They are independent, with image vectors representing image semantics and OpenAI embeddings representing text semantics. Finally, set the indexer to update daily at midnight, creating the data source, index, skill set, and indexer. And now let's check the index. Fields contain the chunked text. OpenAI created text vector with 1536 decimals and image vector with 1024 decimals. I won't comment on 200 lines, of course, but I show you two interesting things. Around line 65, the text vector field definition contains 1536 OpenAI embeddings and a vector search profile reference for converting search questions into embeddings. The same for image vector creation with the cognitive service. The skill set shows all skills in sequence. OCR skills reads images and translates them into text. Merge skill insert extracted text from OCR into the document text. Split skill divides the whole document text, including images, into chunks. Azure OpenAI embedding skill creates embeddings for each chunk, and vision vectorized skill creates image embeddings. The final object is the indexer, combining data source, skill set, and index in about 30 lines, and defines execution frequency. With only 3 documents, it runs successfully in seconds. Check the index, search cheese, and the first result is from the homemade pizza file, of course. Search war, and the first result is from the historical events PDF. The response is long, so I use a JSON editor to see that the responses contain 1024 image embeddings and 1536 text embeddings from OpenAI. And now that we understand how it works, let's delete everything and recreate it from code in less than 10 seconds. Let's open VS Code alongside the Azure portal. We see that there are no data sources, so we create one from the code, and there it appears. Index, initially it's empty too. We send the request, refresh the page, and there it is. Skill set, there is none initially, but we send the command and it appears. And finally, the indexer. This takes a few seconds because it has to start the process of extracting text from PDFs, so-called cracking process, performing OCR, splitting text into chunks, creating embeddings, and inserting all this information into the index. Initially, the indexer status is in progress, but it only takes about 30 seconds and then it's ready. You can then open the index, type tastiera, which is the translation of keyboard, even though the document is in English, and the response is from the Surface PDF, as we could imagine. Just to confirm, the search we performed is hybrid, and we see this setting in the JSON definition of the index around line 100. And to conclude, let's see how the deletion tracking feature works. We delete the Surface PDF using the Azure Storage Explorer. Then we rerun the indexer from code, and now when we try the query for tastiera again, it's not shown by Azure Search because it removed any references to the Surface PDF. Well, I hope this demo clarifies the concepts from the article. I thank you very much for your attention and let me know, please. Arrivederci.